Another, what was it? Another concept I should have learned is explore defining characteristics of cloud computing. Now, I want to try to explain this in a way to where it's something that appeals to a wider audience, but basically, here's sort of the formal explanation. Cloud computing is a technology that uses the internet and remote servers to store and manage data, rather than using a personal computer or local server. The following are some of its defining characteristics. 1. On-demand self-service. Users can provision computing resources such as server time or network storage as needed automatically without requiring human interaction with the service provider. 2. Broad network access. Cloud services are available over the network and can be accessed through standard mechanisms like web browsers by both thick and thin clients, e.g. mobile phones, laptops, and workstations. 3. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. Resources such as storage, processing power, memory, and network bandwidth can be dynamically assigned and reassigned according to the consumer demand. 4. Rapid elasticity. Cloud services can be rapidly and elastically provisioned, in some cases automatically, to quickly scale out and rapidly release, to quickly scale in. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be purchased in any quantity at any time. 5. Measured services. Cloud computing resources usage can be monitored, controlled, reported, and billed accordingly. Both the provider and consumer of the utilized service have a clear view of the service usage, which adds transparency in billing usage. So, that's where the cake kind of gets a bit thick there. Its resources using can be monitored, controlled, reported, billed accordingly. Measured service. Service model 6. Cloud computing is typically divided into 3 service models: infrastructure as a service, platform as a service, and software as a service. There's also firewall as a service too, and I think there might be another one, but those are the 3 basic models that you really need to know. These models define what type of resources are being provided to the consumer. 7. Deployment models. There are different deployment models, including private cloud, resource dedicated to a single organization; public cloud, resources shared across multiple organizations; hybrid cloud, a combination of private and public; and multi-cloud, use of multiple cloud computing and storage services in a single network architecture. Yep. Most people are familiar with public cloud. And you get a lot of services from like Netflix and stuff like that. In essence, cloud computing provides a simple way to access server, storage, database, and a broad set of applications, services over the internet. It's designed to be easier to use, more flexible, scalable, and cost-effective than traditional IT infrastructure. Verse trying to take the bulletin points off, but I don't think it's going to let me. What is these weird mechanisms in Word that cause it to lock up like this? Let's see how much time. So I got this done, doing this stuff in like 10 minutes. Just some simple study things that I do that help out. That it makes OpenAI helps out a lot with, Determine new skill sets required for working in the cloud. Let's see. And I've already covered this yesterday. I might throw too much sand on each module like this, but if I have the time to do it, why not, It's not exactly easy either, but it's easier than how it used to be. DevOps, that's something I don't know too much about. Migration and integration, I touched base on that. Understanding the containers and microservices, programming and scripting skills, data management and analytics, yep. Understanding IT service management, ITSM, certification. As more organizations migrate to the cloud, new skill sets are required for IT professionals to effectively manage and optimize these technologies. Here are some of the key skills necessary for working in the cloud. 1. Understanding of cloud service providers, familiarity with major cloud services providers like Amazon Web Service, Microsoft Azure, Google Cloud Platform is crucial. Each platform has its own set of tools and services and best practices. 2. Cloud security skills. Security in the cloud is a vital concern for most businesses. Professionals should understand concepts like identity and access management, encryption, data protection, and how to set up firewalls and other security measures in a cloud environment. 3. Cloud architecture and design. Understanding how to design and architect a cloud solution, including how to manage and configure virtual networks, is key. This includes understanding concepts like load balancing, fault tolerance, and scalability. 4. Cloud migration and integration. Knowing how to migrate and integrate applications and data from on-premise environment to the cloud is a valuable skill. This might involve using tools like AWS database data migration services and Azure migrate. I think I had to use data migration before. 5. DevOps practices. DevOps practices are commonly used in cloud environment to streamline the process of developing, deploying, and maintaining applications. Skills in areas like continuous integration, continuous delivery, CI or CD, Infrastructure as code, IaaC, and automation are highly valuable. Understanding of containerization and microservices. The use of containerization technologies like Docker and orchestration tools like Kubernetes is becoming more common in cloud environments. Understanding how to use these tools to manage microservices can be a valuable skill. 7. Programming and scripting skills. Having some programming or scripting skills can be useful, particularly in automating tasks in the cloud. Languages such as Python, JavaScript, and shell scripting are often used. 8. Data management and analytics. With the increase of data generation and storage in the cloud, skills in data management, including database design, data warehousing, and big data solutions, are increasingly important. Knowledge of data analytics and tools like Hadoop and Apache Spark can be beneficial. 9. Understanding its service management, ITSM. Familiarity with ITSM frameworks such as ITIL can be beneficial for managing services in a cloud environment. 10. Certification. While not strictly a skill, having cloud certifications can demonstrate your knowledge and expertise in the cloud. There are various cloud certifications available from providers like Amazon Web Service, Google, and Microsoft, as well as vendor-neutral certifications like CompTIA and Cloud Plus or CompTIA Cloud Plus. Building these skills can help IT professionals succeed in the cloud, but in the specific skills needed can depend on your role and the needs of your organization. It's always a good idea to continually learn and adapt as cloud technologies evolve. Yep, and boy, do they evolve, man. Alright, let's see how far I've gotten. Okay. Identify various cloud deployment models, including public cloud, private cloud, hybrid cloud, multi-cloud, and community cloud. I have a pretty good understanding about this, but let's see what OpenAI says about it. Cloud deployment models refer to various ways that cloud environments can be implemented based on organizational requirements and needs. Here are primary types of cloud deployment models. 1. Public cloud. This model is owned and managed by third-party cloud service providers and delivers computing resources such as servers and storage over the internet. With public cloud, all hardware, software, and other supporting infrastructure are owned and managed by the cloud provider. Users access these services and manage their accounts using a web browser. Examples include Amazon Web Development, Microsoft Azure Cloud, Google Cloud Platform. 2. Private cloud. Private cloud refers to computing services offered over the internet or a private internal network to select users only, not the general public. Private clouds may also be owned, managed, and operated by the business itself or a third party, and they may exist on-premise or off-premise. This model provides a higher level of security and privacy. 3. Hybrid cloud. As the name suggests, hybrid cloud combines public and private cloud by allowing data and applications to be shared between them. Hybrid cloud gives businesses greater flexibility, more development options, and helps optimize existing infrastructure, security, and compliance. They can help businesses balance cost efficiencies and flexibility of public cloud with the security and cloud of a private cloud. 4. Multi-cloud. Multi-cloud is the use of multiple cloud computing and storage services in a single network architecture. This refers to the distribution of cloud assets, softwares, applications, and more across several cloud-hosted environments. A multi-cloud environment could be all private, all public, or a combination of both. 5. Community cloud. A community cloud is a collaborative effort in which infrastructure is shared between several organizations from a specific community with common concerns, security, compliance, jurisdiction, etc. Whether managed internally or by a third party and hosted internally or externally, this is more cost effective than a private cloud, but provides a higher level of privacy, security, and other policy compliance than a public cloud. Choosing the right deployment model depends on a variety of factors, including the specific needs of the business, data sensitivity, compliance requirements, and the types of applications being deployed. So, a new concept is community cloud, collaborative effort which infrastructure shared between several organizations. I wasn't really familiar with that, so that's something different. But mainly private, public, hybrid, multi. Okay. And here is one for cybersecurity. Analyze security concerns specific to each cloud service model. Cloud security is a critical concern in each of these three primary service models: infrastructure, or IaaS, PaaS, and SaaS. While many of the security concerns overlap, there are also specific issues that are more relevant on each model. So, for example, infrastructure as a service gives users the most control over security as they manage the operating system and applications. But this also means that they are responsible for a larger share of security concerns. 1. Data security. Users must secure their own data, which can be particularly complex if the data is distributed across multiple IaaS platforms. 2. Network security. Users are responsible for securing their own network connections, often via virtual private networks or other encryption technologies. 3. Access control. Users must manage their own systems for managing access control, including roles and permissions. 4. System vulnerabilities. Users are responsible for keeping their own systems and applications up to date and patched against own vulnerabilities. So it seems like they got a lot to worry about there for IaaS. And it's other encryption techniques, not technologies, forgive me. Platform as a service. PaaS users have control over their application data, but the platform provider is responsible for securing the underlying infrastructure. 1. Data security. Users must still secure their data and must do so within the constraints of the platform. 2. Application vulnerabilities. Users are responsible for securing their own applications against exploits and other vulnerabilities. 3. Access control. PaaS users must manage their own access control systems within their applications. Software as a service. SaaS providers manage the infrastructure and platform in which the software runs. Users are largely only responsible for securing their own data. 1. Data security. Users must secure their own data, but within the constraints of their software platform. This often means that the provider's tools for encryption, access control, and other security measures. 2. Access control. Users must manage access to their SaaS applications, often using provider tools. 3. Dependency on provider. In SaaS, the security of your data and applications depend heavily on security measures put in place by the provider. Therefore, it's crucial to evaluate the security measures and certifications of this SaaS provider. In each case, it's important to remember the shared responsibility model. While cloud providers have robust security controls in place to protect the infrastructure and services they provide, customers are also responsible for implementing and managing security controls for the aspects of the cloud environment they control, like their data and user access. All right, I think I'm going to pause here for a minute. Yep, not a bad study session.